Hello, welcome. Today we're going to be solving this problem. We told ourselves that for us to be able to design a reactor, fixed bed, plug flow, or any of the kinds, the most important thing is to determine things like the diameter of the bed or the length of the bed. So we have a given problem where we're going to be studying and be solving for this diameter. So let's take this question. I'm recording this on my own. Today is a Sunday, so my workers are not around, and I have to do this because of tomorrow's exams. So please follow these steps line by line. You'll be able to understand. Now, this is the question. The feed to the first stage. This is the question 1 in the exercise. The feed to the first stage of a sulfur dioxide converter at 100 kilopascal and 700 Kelvin contains 9.5 mole percent SO2, 11.5 mole percent O2, and 79% N2. The feed rate of SO2 is 7.5 kilograms per second. The mass of catalyst is 6,000 Kelvin. The bed voltage is 0.45. The bulk density of the bed is 500 kilogram meter squared cubed. The effective particle diameter dp is 15 millimeters. The fluid viscosity UF is 3.8 times 10 to the power minus 5 kilogram per meter per second. The allowable pressure drop is 2.5 kilopascal. Calculate the bed diameter D and the bed length in meters, assuming fluid viscosity and density to be constant. So that is the question. It's already there. You have it. So now we're going to be looking at the solution. Very, very important. Look at this solution very well. You'll see that the first thing that we tried to find is the mass flow rate. And the mass flow rate is simply the summation of the various masses. You can see it here. This is the first thing that we are supposed to find, the mass flow rate. And you know that the component mixture are SO2, O2, and N2. So the combination of all, the summation of their mass flow rate is equal to the total mass flow rate. But we only have the mass flow rate of this, but we have the molar percentage of these two. So we'll try to use this to find the whole of them. So another way you can express this is by saying mass flow rate of this. Mass flow rate of O2 is also the same thing as mole fraction of O2 times the total feed flow rate times molar mass of O2, which is the same as that for N2 too. So this is another expression for this. But we already know that total flow rate is the same thing as mass flow rate of one of them, say O2, all over its molar fraction, mole fraction times its molecular weight. So with that we can find the total feed rate. So we already given that the mass flow rate for SO2 is 7.25 all over its mole fraction, 0.095 times its molecular weight, to give us 1.191 kilomole per second as the total feed rate. So with the total feed rate known, we can use back this very equation, this plus this plus this, to find the total mass flow rate. And that is what we did here. This total mass flow rate. So this is the mass flow rate for SO2. Then for the mass flow rate of O2, we use the SO2, the S of O2, that's the mole fraction of this, which is 0.115 times the total feed rate FT. This is the formula we are using, this very formula, SO2 FT MO2. So SO2 is this, XO2, which is the mole fraction of oxygen, feed rate, molecular weight of oxygen, plus mole fraction of nitrogen, feed rate, molecular weight of nitrogen. Everything, if we add it up, it will give us 38.0 kilojoules. So having found the mole mass flow rate, We now assume ideal gas behavior in order for us to find the density of the feed. And we know that density PF of the feed is equal to PM over RT. But because we don't have MAV, we replace it with M over FT. So we now have P, which is the pressure, times M over FT, which we already know, all over RT. So if you fix that very equation, we are going to have P is already given. It gave us P. In the question, the P is 100 kilopascal. So if you convert from kilopascal to pascal, we have 100,000. Then we have our M over FT, which is 38 over 1191. We are changing to 119 from kilomole per second to mole per second. That's why we're having 1191. Then all over RT, R is 8.3145 and T, which is temperature, is 700. So we have 0.58 kilogram per meter cubed. So having done that, now we'll now use the formulas. We are expecting the teacher to give us all these formulas. So we just substitute. For alpha, we substitute all the values. EB, all these things are already given. We get alpha to be 10.56. For beta, we substitute all these values. We get beta to be 2.47 times 10 to the power minus 3 per square meters. Then for K, we substitute all these values as well to get it to be 18.405 meter to the power 6. Then for D, we substitute the values of our alpha, beta, and K. Alpha first, make sure that you take note of how these we are gotten. You must get the alpha first because you might be using it to calculate your K. So you get the alpha, beta, then K. Then for D, you fix this formula, D6 minus BKD2 all minus K equal to 0. Then using trial and error method, you find your value of D, which we are told that will be given. So that using the formula L equal to 4W all over BB pi D squared, we can now have L to be equal to 4 times 600 all over 500 times 3.142 times what will be our D squared. So if I are assuming our D to be 5.4, and you're going to be 5.2, and it's going to be 5.2 squared. So press the calculator and get our final answer. So that's how you go about it. So I'm gonna put this to take the whole and also show you again. Once you're starting your solution, just first thing you're supposed to calculate is the total molar flow rate, which you can get from the molar feed rate of SO2 plus that of O2 plus that of N2. But you know that you're not given that of O2 and N2. So first of all, use that of SO2 that you have to find the total feed rate, which is FT. So you're going to be having a formula that will have mass flow rate for SO2 all over its mole fraction times its molecular mass to give us 1.191. Then using that FT that you found, fix it back in the former general formula that says M equal to MSO2 plus XO2 FT MO2 plus XN2 FT MN2. So fixing it in that, you find your total M. So without your M, find the density of the feed using the formula that density of feed is equal to PM over RT. M is not given there, so we have P M dot all over FT over RT, which will give you the value of 0.548. Then use the other formulas that will be given most likely to you to substitute to get the values of alpha, beta, K, and D. Then finally use the formula L equal to 4W over bed density times pi times D squared to get your final value of length. So with that, that's how you solve this. Please take notes. You can copy this down, study it very well. Like our video, share it. Thank you, and God bless you. See you tomorrow.